Hi and welcome to TRX Bench. Well, it's ICOM time again. I have a IC-7100 here again on the bench, and this time this radio died during a normal 2-meter operation in receive. So there is no receive anymore, and we do not really know what has happened. So let us have a look inside the radio and find out what's going on, shall we? Okay, so the radio's already up and running. So we are on 145/300. So that is VHF, and yeah, so let me switch on our generator and let's see what's going on. So I'm feeding 145/300, but there is nothing. So it is minus 80 dBm, and that is the setting we have right now, and with minus 80 dBm we should have already full receive, so better than S9, but radio is quiet. So now we may hear in the background the static, so let us increase here our amplitude, and let's see. So we have, of course, our generator, our modulation switched in, and yeah, let's see what's going on. So we are really increasing our amplitude. So now we can hear the tone. Yeah, and let me put it down a little bit, and you see with minus 12 dBm, which is really a big amplitude, we do not already see S1, so that definitely means that something is wrong with VHF, so the receiver is more or less deaf, so it is not working. Now to get a better feeling what's really going on, let's check what we have on 70 centimeter. Okay, so the radio is set to 430.100, so as the signal generator, and level is minus 80 dBm. And let me switch it in, and yeah, have a look. So we have S9 plus what might it be, plus 10, 15, whatever. So that is what we would expect, so that is just fine. So that means UHF is working just fine. And let us check HF as well, but normally HF is a completely different path, because we have to use a different antenna jack. But just to be sure that everything is fine, I will change here my let me see if we can see it. Yeah, so I have to change here my input. So this is here our HF antenna, and as I said, it is a completely different signal path, but just to be sure what's really going on. Okay, 20 meter band and minus 73 dBm, so let me switch it in. And yeah, absolutely fine. S9 with minus 73 dBm, so that is absolutely what we would expect. And yeah, so we have confirmed that there is something wrong on 2 meter, so definitely a very low receive. And therefore let us have a look into our schematic, and then we need to crack open the radio. Okay, so here is our overview, and we have here our both antenna inputs or outputs, whatever. And that means we have here for HF and 50 and 70 megahertz, and this here is for 145 and for 30. So we have these two signal passes, and let's go here into it a little bit more. So yeah, we can see here our antenna jack 144 430, and you see the green line is our receive line, and of course we have here some filtering, and then low pass filter, and of course here for our 70 centimeter pass a high pass filter, and then of course here in this pass for 2 meter a low pass filter. And you see that at this point our both bands gets already separated, so that we get the own parse for 144 and for 430. We already know that our 430 megahertz pass is just fine. So that means here in this pass here is everything fine, and at this point here our 70 centimeter and our 2 meter pass are getting together again. So that means our problem can be somewhere from, yeah, let me say here, this low pass filter, or maybe this junction here, anyways, up to this point. Alright? So that means we need to focus here on this area here. So of course we have all the switching here. If it is 70 centimeter or 2 meter, we have the band switches here, which are adjusting for the one or the other, and yeah, you can see it here. So this is our V bands, and of course then we have here somewhere our U presettings and whatever, and therefore we need to concentrate here onto this area, and that is what we want to look more in detail on our voltage diagram. And of course all this here is already here on the PA unit, so that is where our antenna jacks are, and that means all the switchings and the pre-amplification is already on the PA unit. So therefore we need to go here to our PA unit, and there we have here our different, let me see that we can zoom in a bit better, and I hope you can see it. So this here is our 70 centimeter pass, which is good. and this here is our 2 meter pass, which is bad. And we start here at let me see, somewhere here where we have here our C440, our junction, and we check if something is wrong here, or where something is wrong here in this pass. So that is what we gonna do. And yeah, this is here our first transistor. This is a double gate MOS-FET transistor here, and we should focus on this transistor here, because I believe this could be a potential problem area. So yeah, let's start and go through step by step. Okay, and here we have our PA unit, and of course we have here our both antenna jacks for HF and for all the VHF and UHF frequencies. And according to our PCB plan, we have here our two, so let me go a little bit more here into the circuit. And yeah, according to our PCB plan, we find here our two signal passes for 2 meter and for 70 centimeters. So this here is obviously, I have to double check, but this is obviously here our 70 centimeter pass, and this here is our 2 meter pass. So, and the easiest way is now to start here with the first filter, and I believe it is somewhere around here. So we need, of course, to double check, but then yeah, we can definitely directly start in our probing. Yeah, and as I said, this is here our board layout. So this is the top view, exactly how we are viewing or looking onto it. And if I zoom it in here a little bit better, you see here this both passes, what we have already talking about. And let me go back to the schematic, so then we can directly identify where we should start testing. And as I already said, maybe it is the easiest way to start directly here to take our first measurement. So this is here our L551, and yeah, when I go over to our board layout here, then we can see, yeah, let me zoom in a little bit, but then we can see that this here is our L551, and yeah, that is the right pass here on the PCB. Just to get the orientation back, when I zoom in, we already said we have here our both passes, and this one here is 2 meter, which is faulty, and this here, let me double check with our PCB plan. Yeah, so I go deeper, I zoom in a bit more. That is obviously too much, but anyways, this way you should be able to see it. So this here is our L551, and yeah, as I said, for a simplification, I directly start testing here, because this is easy. I do not really need to find here my way through here all these filters and what have we, so we know that our signal has to be here, and if it is here, fine, we can go ahead. If not, we have to go back, of course. Okay, so what we do right now is we take here the level as a reference, and after that we test here at our L551 and see what the level is down here, and then we can decide how to go ahead. Okay, and I'm now probing here down at the RF input. So you see we have here minus 73 dBm, and that is just fine. And here is our carrier, so it is unmodulated. And now I go down to our coil L551, and let me see what we have down there. And you see our spectrum analyzer is reporting minus 66 dBm, so that is even a higher level as we have seen it directly at the antenna jack. So I mean, we have definitely some impedance problems here on the way until we get here to this L551, and therefore we are reading here a higher level. So but this is not the important information. The important information is that we have here still a significant level, which is telling us that everything down to this point will be fine, and we can now really go ahead. Okay, and now I have to change my technique here a little bit, as I'm getting more and more impedance problem while testing with the spectrum analyzer. So I just decided to go ahead here with a signal injection, and let me see that we here have all together. You see that you can see it as much or as best as possible. That is a little bit problematic, but anyways, I'm here with my injector, and I try to feed in the signal here at our what was it, 551. Signal is now modulated, and we definitely hear nothing. So I'm now interested to go down here to the gate and try to inject my signal down here, and as you can hear, there's definitely nothing. So therefore we go to the output, and there is another coil. It is the L555, this guy here, and we try to inject it here. And you hear this? So we definitely have a signal down here, and it is present here at our coil, and as well as the coupling capacitor, which is this little guy here. And you see we have signal, and when we watch our S meter, we can see the following. Okay, first of all I test once again at the input of our dual gate MOSFET. Now I'm just injecting and watch here the S meter, so there is nothing. I go now to the output and let's see what we have down there. And watch this, we have S9. So I'm feeding minus 70 dBm, and that is definitely a mismatch here, but you see behind our dual MOSFET we have our signal, and this is here the same at the little coupling capacitor, and you see our signal is nice and strong. So therefore I believe that we have here a problem with our dual MOSFET. Okay, so what have we done? So we tried to inject our signal here into our dual MOSFET transistor, and we heard no signal at the speaker, and then we feeded it here in our L, or at here the upper point of the L555, and we had a nice and strong output signal, and this is a little coupling capacitor where we checked, of course, for our signal as well, and it was present as well. So now it is possible that this double gate MOSFET is dead, but on the other hand it might be that our supply voltage is not present, and if we look down there, so we see we should have 8 volt here, and this 8 volt will go here over this R564. It is a 12 ohm resistor over our L555 to feed our dual gate FET with supply voltage on one hand, and on the other hand we need here at our second gate, gate 2 normally, we should have a kind of bias, or we can call it a preset voltage for the amplification. And what you can see is that it is also connected here to our 8 volt line, but there is a 560 ohm resistor, and that is then feeding here over this voltage divider, of course, our second gate, and we need to check if we have a voltage, a DC voltage at our second gate as well, and if these both voltages are there, then we can really nearly sure that our Q, 551 is gone. Okay, so then let's start probing. First of all, for our 8 volt line, which should be down at our R564, and that is this guy here, and here we are, 7.9, so that is close enough, so we can say that our 8 volt line is present. And now let's check at our FET. What do we have down there? So that is it is a little bit difficult here, because these components are really so small that I can't really see them. So let me go simply here to our L555, and you see we really have our 8 volt at our FET, so that means the 12 ohm resistor and the coil itself is working if we talk about DC, so that means supply voltage is given. Now as we said before, we want to see if our G2 voltage is also there, which comes, as we have seen, over the same supply line. So therefore I have to go down to our G2, and once again I almost can't really see, it is so tiny here through the camera. And what do, yeah, so that looks pretty nice. So approximately 3 volt at G2 tells me that that voltage is fine as well, and that means for the moment in time it really tells us that this little dual gate MOSFET is simply done, and we need to replace it. And then we see if there is maybe a second problem, or is it really only this little, let me go down here to the PCB, and you really can see how tiny this dual gate MOSFET is. So that is again almost nothing. Even this L555, which is our supply coil, is as you can easily see bigger. So yeah, therefore we have to replace this transistor, and then yeah, let's see what's going on. I mean, what is it? Let me check. It is a 3SK293, and that is a dual gate MOSFET, which is also used in, I'm not sure if I am really remember right, but I believe it is also used in Alinco radios, and it may be that I have one still on stock. So that is what I'm gonna check right now. Yeah, and fortunately I was right. So there are 2 transistors left, 3SK293. So very nice. Here you really can see how small they are, and yeah, so let's replace this transistor here into the radio, and let's see if it will be then back alive. Alright, as you already can see, I covered here the components around with Coptan, so that we can help not to destroy what we have around. And now I try to get the component out of the circuit, and yeah, that we can finally replace a new one into it. Okay, so I was able to lift it off, and now I have to clean the pads, and then we want to replace a new one into it. Okay, so our new transistor is in down there, And now let's finger cross that everything works fine and that we do not have an additional problem somewhere down there. Okay, so radio is switched on, and yeah, setting is right, transistor is in. Now I switch on our signal generator and let's see if it works. Wow, sounds good. So minus 73 dBm. So on HF that would mean S9. But ooh, no S meter. No S meter. So let me reduce here my input level a little bit. Okay. And we are going in the noise. So that is minus 85 dBm, and we should minimum be able to go down to 120. We need to double check our specs, but I can already say so that is minus 70, and you see, so that is minus 60. So what we can say so far is that definitely this double gate MOSFET, or not MOSFET, FET was faulty. So that is for sure, because we already have a signal with minus 73, even if we do not see any on the S meter. So that means there is an additional fault. Okay, let's have a look into the schematic and let's think what we will do next. Okay, so what we can see so far is, before whatever happens, the double gate FET is jeopardized. We have here a couple of diodes as well, and yeah, both diodes here are really right at the input of this circuit, and I believe these are protection diodes, because we have here very low resistors. I hope you can see it. Let me zoom in maybe a little bit more, so maybe now it is better. So you see we have here 47, and here we have 33 ohm, and then we have directly these diodes to ground, and that means that if there is a over signal, let me turn it down here, if there is a over signal, this diodes should really pull this strong signal to ground, that it will not be able to damage our circuit. And well, you remember that I had with my spectrum analyzer, I was able to pick here my signal, but then when I tried to go more into the direction of our FET, that I had the assumption that something is wrong with the impedance, and I thought, okay, that is the faulty transistor, but I now think that there is something else. So let us check this both diodes, I mean this here are cap diodes, so this is a band pass filter, and this filter can be moved with a changing frequency. So therefore we have here cap diodes to move the filter together with a changing frequency. I hope that this cap diodes are fine. So let us check here this diodes first, and then we go ahead, okay? Okay, so it is now really difficult to do here the testing. So I've set the meter to a diode test, and let me test this both diodes. I have to use here my microscope to have a better view here on the board. And yeah, let me go down to the first diode, which is here. And this diode seems to be fine. Let me do it reverse. And reverse. Yeah, it is fine. And the second one is fine as well. So the diodes are good, but we have seen that there are very, very low resistors, and the first one was a 4.7. so let me check the 4.7. Even here in circuit we should test minimum 4.7 or even lower. So let me see. I go down here now to the first resistor, and what can we read? 1.3. So that is mega ohm. Yeah, that is definitely wrong. So let me check the second one as well. And the second one is a 33 ohm resistor. Let me go down to this resistor. What do we test here? So 33 or lower should be right. 30. That is kilo ohm. That is not ohm. That is kilo ohm. So this both transistors are toasted. Okay. So that means yeah, we have to take this both this both resistors out of the circuit, and as long I'm right, and this both diodes go down, and, you can see it here in circuit. Okay. So we are talking currently here about this diode, and here we have our both resistors, which are high resistance, and so they are definitely toasted. And when I'm right that these both diodes are for protection, then we can take this resistor simply out, and for testing purposes, right, we can run the circuit without this both resistors, because we know that we are feeding a low signal into our circuit, which will not be able to open this diodes. So we are far away from 0.5 7 volt, which are needed to make them low resistance. So therefore we can simply take this both resistors where we think they are toasted and can check our circuit once again. Yeah, and I will do this job here with my tweezers, and let me take out this both resistors, and then we can go ahead. So I really have to apologize, I can't do it on camera as it is all so tiny, and yeah, sorry, it is impossible. Okay, here are our both resistors, and we can test them out of circuit. So let's see that we really can see both. Somehow it should work. Okay. Not funny. Maybe that way. Let's see. So that is our first resistor, which is 3.3 mega, and this here is the second one, which is 25 kilo. So they are definitely toasted, but my conclusion was not entirely right. Of course, if they are already high resistance, so this one and this one, then it is more or less the same if we leave them in or we take them out. So besides the fact that this both resistor is simply burned off, we have an additional problem, and that is now really the question: is there really maybe one of these diodes toasted, or what is our problem here? So yeah, let's go ahead and test where our problem is right now. Well, and when we think about it, we remember when we tested it first time, we were able to pick here our signal with the spectrum analyzer. Okay, so we have seen that this resistor and this resistor really burned off. Okay, so we have here an coil, an inductivity in between, and we know that an inductivity is normally DC wise very low resistance. So if there was a current flow through, and I mean there was a current flow, because otherwise this resistor wouldn't burn off, so there was of course a current flow, and therefore we need to check if this coil here is simply good. And in circuit we can do it with resistance test, because we know DC wise a coil has a very low resistor. So before we go ahead, let us simply check this coil to be sure that it is working fine. Okay, so let's try to do it here through camera. So we have switched it to beeper, and already some problems here, and our component of interest is this here down there. And yeah, let me simply go down here and let's check what we have. Nothing, once again. Yeah, it is okay. And here is definitely nothing. So let me take off the beeper, and let's really check for resistance. And yeah, so this is really open. So this coil here is obviously blown together with the both resistors. Okay, so we need to get this coil out of circuit to see. I don't know if I have a coil to replace it, but let me see if we can check it a different way. Okay, we can test it here quick and dirty. So you hear this is a signal, but it is low sensitivity as we had it before. No indication here on our S meter. And now I go down here into the circuit and simply short this coil of interest where we think that it is burned. Let me go down here and let's short it. You hear that? You hear that there is noise in the background, and when I go and short it, then it is fine. And a very good proof is, let me do it this way here. I make it a little bit, I take it down a little bit. So now I do exactly the same. I hope that I do not short out anything else here. That wouldn't be fine. Alright, and you can see this here. Now we have a good signal with minus 73 dBm, and that means our coil L551 22 nanohenry is burnt too, so we have to replace it as well. Alright, so here are our replacement parts. So these are our new coils, and so I'm gonna replace the coil first, and then we can go for the resistors as well. Okay, so our new coil is in. Let's see if you can see it. Yeah, it is down here, and what you can see here, so this is one of the new resistors which is not soldered in right now, so I will do it later. And you may also see this is one size bigger than what is here in our circuit, but it will fit anyway, so no problem to put this size in, so that is just fine. But as I said, of course the circuit works without this resistors, so most important is here our coil, which is in now, the new one. And yeah, let's see, let me switch on the RF generator, and let's see, and let me turn off on here our volume, and very nice and clear tone, and have a look, very nice. So now we have a strong signal, so we are at minus 73 dBm, but that is of course not our VHF level for S9, and that's the reason why you see here plus 10 or plus 15, whatever it is. So let's check for sensitivity. Okay, first of all we check for S9 on VHF, which means minus 93 dBm. So minus 93 dBm is S9 on VHF. So let me reduce my my generator to minus 93, which we have now. And yeah, of course, a very nice S9 sign, and yeah, let you see that everything is right. So it is minus 93 dBm. Let me go back here to the radio, so you see that is just working fine. Okay, and after repair like this, we are of course interested in the sensitivity, and we find FM with 12 dB SINET on 144 megahertz, and preamp has to be switched on, and 0.18 microvolt represents minus 122 dBm. So that is what our receiver must be able to deliver, and of course that is what we are really interested in. Alright, so we need to reduce now our level to, so we have a bit tone here in the background, and I can see already the scope. I will show you later. Now we need to reduce here our output level to minus 122, and you may already hear a little bit in the background that it starts becoming noisy. And remember, minus 125 is really 122 is really only 0.18 microvolts, so that is really small. And yeah, let's see what we have on our SINET meter, and I will simply here go over to our SINET meter, and here we are. So that is our SINET value, and what you can see, of course it is a little bit jumping, of course. That is because our signal is really noisy. You can see it here. So that is the audio with this low level, but our specs are requiring 12 dB, 12 dB SINET, and you see in average we are definitely at 12 dB. So that means sensitivity is just fine. Everything is really working very good. And as I already said, we finally need to put in here our new resistors, and this here is our 33 ohm resistor, which needs to go down here. And you see it is for sure a different size. It is not that small what we have originally here in our circuit, but well, it will fit. You see how funny it is here, and through the camera it is much more funny, believe me. Anyways, you see it will fit here, and that is what I'm gonna do right now. I will fit it in here, and then we are very close to the point that our radio is back working. Alright, and our new resistors are in, even if they are a little bit too big, and you see they after all they fit, and that is what is really important to us. Another interesting information may be, so this here should be a 4.7 ohm resistor, and I was not able to get a 4.7 ohm resistor, and I really was a little bit in a hurry to get this radio ready, because the old man likes to have it back. So you can really do this. I put one on the other, so that means 210 ohm in parallel, which is 5 ohm, and we have then finally the same result. So you see, if you are in a hurry, and if you need to look for a different solution, so that could be a good way. Alright, so yeah, we have seen radio was working just fine. Everything is okay. Our receive is just fine. Sensitivity is given according our specs. That means this radio can back to its owner, and we are at the end of this video. I hope it was a little bit interesting for you. Thank you very much for watching, and yeah, see you next time. Bye.